So in this tutorial we are going to discuss about the insertion sort algorithm, which is used to sort a given integer values. So I will explain insertion sort using an example of a cards. So let's suppose we have 5 cards. I'm going to draw 5 cards here, and we are going to assign each card an integer value. So these are the 5 cards that we have, and let's suppose I am going to insert some values, or I'm going to assign values to these cards, which is 12, 11, 13, 5 and 6. So these cards you can see that these are in an unsorted manner. So our task is to sort these cards in the ascending order, and let's suppose that these cards are physical in nature, so you can actually pick up a particular card and place it at its proper position. So the ascending order, or you can say the result of the sorting algorithm, should be 5, then 6, then 11, 12 and 13. So the basic idea of insertion sort is to pick up a card. So I'll write here, pick up a card, pick a card and insert that card, and insert that card at its appropriate position in the set of previous cards. So what we are just going to do is we are going to pick up a card, and we will place that card at its appropriate position, and appropriate position means that it should follow the ascending order rule. And we are going to place this card in the set of previous cards. So let's now do the insertion sort algorithm on these cards. So first of all, let's pick up the first card, which is 12, and we know that 12 has no previous set of cards, so we are not going to pick the first element or the first card. So let's move on to the next one, which is 11. So you can see that this is a 11 card and it has previous set of cards as 12. So what we are going to do is we are going to pick up this card first. So we have picked 11, and what we are just going to do is we are going to place this card at its appropriate position. And since we know in the ascending order the previous element has value lesser than the next value, so as a rule we will have to place this card over here. So this is the first pass. So now in the next pass, which is 2, or you can say in the next step, we are going to create, so the cards will they will look something like this. So 11 will come here, and then 12 will come here, then 13, 5 and 6. So now what we are going to do is we are going to pick up the next card, which is 13. So you can see that the previous set of cards, if we choose 13 as a card, are 11 and 12. So what we will have to do is we will have to place this card at its perfect position, or you can say the appropriate position. So since 13 is already at its appropriate position, we are not going to do anything. In the third step, so I'm going to mark it as 3 now. In the third step, we are going to consider the next card, which is 5. So now what I'm just going to do is I will pick up this card, and now we know that this is the previous set of cards, which is 11, 12 and 13, and I will pick up this card 5 and I will place this card at its appropriate position. So we know that the appropriate position will be here. So in the next step, which is the fourth step, our cards will look like this. So 5 will come here, then 11, 12, 13 and 6. So our card 5 is moved to this position, which is the appropriate position. Now we are going to consider the next card, and we know that the previous set of cards is 5, 11, 12 and 13. So what I will do is I will just pick up this card with value 6 and I will find the position where I should place this. So we know that 6 should be inserted at this place. So I will just pick this card and I will place it here. So in the fifth step, we will get the sorted array, or the cards that we have is sorted now. So this is the basic idea behind the insertion sort. We will just pick up the card and we will just move it at its appropriate position in the set of previous cards. So this is the main idea behind the insertion sort. So we are actually inserting the card at its appropriate position. So let's see how we can just implement this whole algorithm of insertion in programming. So let's suppose we have an array, integer array, with the same elements which we have considered in the previous example, and this is 12, 11, 13, 5 and 6. So what we are now going to do is we will consider this array 12, 11, 13, 5 and 6. So the first thing that we are going to do in the algorithm part is we will pass this array to the insertion sort function, and so this is basically our array. Let me divide all these elements first. So now let's move on to the algorithm part. So the first thing that I will do is I will run a for loop which will run from the first position till the last position. And the reason why we are not going to do this for loop from 0 position till the nth position or the size -1 position is because the first element does not have any previous set of elements. So we are going to run the for loop from int I equals to 1, and it will run until and unless the value of I is less than n, and we will increment the value of I by 1 because after every pass we are just going to take the next card. So let's suppose in the first place the value of I is equals to 1, which is the first pass. So the value at this position is assigned as key. So the card that we have picked, we are going to assign it as to a variable key. So key is also an integer variable which stores the value of the card which you have picked, because we will have to move this card to its appropriate position. We will have to store this value to some variable. So we have chosen the key variable to store the value at the position I. So Next we are going to do what we are going to do is we are going to assign the value of j equals I minus 1. So the reason behind this is j equals I minus 1, and we know that I is equals to 1 in the first pass. So the value of j will be I minus 1, which is 0. So what we are going to do is we are going to compare this element at the, or you can say we are going to compare this card with the previous cards. So the loop will have to run from the I minus 1 position. So this is basically I minus 1 position, and it will run from the I minus 1 position until and unless the value of j becomes less than 0. So I'm just going to create a nested loop here. So we know that the value of key equals I position. So I will create a nested loop, and this nested loop will run from int j. We have already defined integer value here, which is int j. So we will run this for loop. No, we will just create a while loop in this case, not the for loop. So because we will have to compare it with the previous set of cards, so we will just write the while loop, which will run until and unless the value of j becomes less than 0. So while the value of j is less than equal to 0, this loop will run, and is used it is an operator which is used to compare. So if this condition and the other condition, which is the array j position, should be greater than the key position. So if both of these conditions are true, then only we are going to run this while loop. So what are these conditions? So this condition says that the value of j, or j is handling the previous set of cards from a particular card, which is array ith position. So this value of j can never be less than 0. So let's suppose if we are at I equals to 2 position, then the j will be I minus 1, and it will run from I minus 1 position, and it will then go to the 0th card, but it cannot be less than 0. It can be equal to 0. So the next condition is the main condition, which checks whether the value at the position j is greater than key. So we know that key is the card that we have selected, and if the value of key is less than the value at j position, then what we'll have to do is we know that we will have to place this card before that. So algorithmically, what we are just going to do is we will assign this position, we will assign the array j plus 1 position. So we know that this is the j position is 0, so the j plus 1 position will be 1. So we will assign the value at j plus 1 position as the previous value. So when we will run this line, the output will be like this. It will be 12, 11, this will also be 12, then 13, then 5, and then 6. So this is basically a comment here. So what I have done is we have just placed the previous value here, because we will have to place this card before this card. So what I will just do is I will assign the previous value to this one, and then I will decrement the value of j by 1. So since j was at 0 position, then it will go to one lesser position. So the value of j will become minus 1, and since it is -1, this while loop will not work. So after this while loop will work, you can see that the array is 12, 12, 13, 5 and 6. So this should be 11. We know that the card was originally at this position and we are now going to move it here. So first what we will do is we will copy the value of the j+1 position, the j position at the j+1 position. So this will get copied at this one, at this place, and after doing that you will realize that you have actually changed the value at the ith position. So the value of the card was 11, so we have actually lost the value 11. So that's the main reason why we have stored the array I position to the key. So what we will do is we will just assign the array j+1 position equals to key. So we know that now the j is having the value -1, so j+1 will be 0. So the array 0 position will become equal to key, and key was 11. So after this line what we will get is 11, 12, 13, 5 and 6. So you can see that after running this while loop and this single statement, we have actually algorithmically we have placed this card at its specific position. So now the array after this pass I equals to 1 will look like 11, 12, 13, 5 and 6. So now what we are going to do is we are going to pick up the next card, which is 13, and then we will assign it to the key variable. And the reason for assigning it as to the key variable is because we will lose this value at I position due to this assignment. So that's the main reason we are assigning it to the key variable. So this is the card that we are going to pick. Now what we will do is we will run this loop. I becomes equal to 2. So now I will be equals to 2. And in this while loop you can see that the value of j will become I minus 1, which is 1. So the value of j becomes 1. So j is actually now pointing to this position, or I can mark it as here. So this is the j position and this is the I position. So what we are going to do is we are going to compare this key which is 13, and we are going to compare the value at the j position, which you can see in this step. So this is the second step and this is the first step. And remember that the value of j can never be less than 0. So since j equals to 1, so and the array of we will compare this one. So the value of key is 13, and you can see that it is not less than 12. So this while loop will not run because this condition evaluates to be false. So we will come out of the loop. So in the next iteration the value of I will be 3. So now what we are going to do is the array will look like 11, 12, 13, 5 and 6. So we are now going to pick up the next element, which is at the third position. So now I equals to 3. So this is the card that we are going to pick. And now what I will do is I will assign it this value as to the key variable. And now since we will have to compare this in this set, we will use this while loop. And we know that the value of j will be I minus 1. So I is 3. So j will be 2. So since value of j equals to 2 and the array at j position is equals to 13. So now we are going to compare this array j position is greater than key. So you can see that the key value is lesser than this one. So what we will do is we will just in this this is the third step. In the third step we are just going to assign this value to here. So now the array will become 5 so this will be 13 and 13 gets copied here. So since 13 has been copied to the next position, and we know that we will have to insert 5 also, so what we are just going to do is the value of j will get decrement by 1. So since j was equal to 2, now j will become equal to 1. So this is 1 2 3 4. So j will be pointing to this position. So now what we will do is we will again compare the value of j. So the value of j is less than equal to 0. So the first case is true. The second case says that the value at the j position, which is 12, should be greater than the key. So this is not true. So we are going to come out of the loop. So the value at so j will be here. So now what we will do is we will insert the array j plus 1 position as the key. So first let's check this condition, array j is equals to 12 and the value of key is equals to 5. So remember, we are going to compare it with the key and not the value at the I position. So we know that the value of key is still less than this array j position. So what we will do is we will again come in this while loop and we will do this assignment. So array j plus 1 position will get so array j position gets copied here. So the array will now look like this: 11, 12, 12, 13 and 6. So our array will look like this. And the j position will again become j equals 1. So now these are the index positions. Point to this one, j will be equal to 0 now, because in this case j was equals to 1. So now what we will do is, since j is pointing to this position, we will compare this value with our key, which was 5. So 5 is lesser than the 11. So what we are going to do is we are again going to copy this j position to the j plus 1 position. So in the next step, our array will look like this. It will be 11 and 11 gets copied to the next position, then 12, then 13, then 6. So since the value of j is 0, and now after this step the value of j becomes equal to -1, so this while loop will not run. And in the last step, what we are going to do is we are going to assign the array j plus 1 position as the key. So j plus 1 position is the j equals to 0 position, which is this one, and the value of key was equal to 5, so we are going to assign this as 5. So you can see that after using this while loop and all the conditions and this copying of value of j and j plus 1, we can actually place a card which is 5 is placed at its appropriate position in the previous set of cards. So this is the basic idea behind the insertion sort, and this is the program which I have explained. So this is the whole working of the program. So let's now implement this function in the editor. So I've already created this array. So let's create the array 12 11, 13, 5 and 6. So this is our array, and in the insert sort function I will create I variable, then key, and then j. Then I will create the for loop which runs from int I equals 1, and it will run till I is less than size, and we will increment the value of I by 1, and we are going to assign the key value as the array I value, or the value at the ith position. And now we will assign the value of j as I minus 1, because we will have to take care of, we will have to place the card in the previous set of cards. So now what I'm just going to do is I will create a while loop with these two conditions which we have already discussed, and the value at array j position should be greater than key. So after writing this condition, this while loop will assign the j plus 1 position to the array j position, and after this it will decrement the value of j by 1, and after this while loop will end, and this is going to end until and unless the value of j is less than equal to 0. So what we will have to do is we will just have to assign the j plus 1 position, the j plus 1 position as the key. So this is our insert sort function, and this will sort our array. So let's run this program, g++ test.cpp. So basically I forgot to print out all the elements of this array, so I will just create a loop that runs from 0 till I less than size, then I++, and this will just print out the value of array ith position like this. So let's run it again. First I will compile it, and then let's run it. So you can see here that the array given to us was 11, 12, 13, 5. So this is basically after the first, you can see that this is our first iteration. So we have done there is a problem in this program. So the main error I'm going to find is there should be size minus 1. So the error is here, the value of n is not equal to 4, it is equal to 5 in this case, and this should be size. So let's run this program again. Okay, so I forgot to save it. Again compiling. So now you can see that after the first pass, the value, the array will look like this: 11, 12, 13, 5 and 6. So if I will just write this for loop and run this for loop from, so you can see that this is not the desired output. So this means that we have made some mistake. Okay, so the value of j should be greater than equal to 0. So I will compile this again, and let's see if we will get the correct output at this time. So yes, you can see that this was the main error. The value of j should be greater than 0. So we will get the desired output. You can see that this is the sorted array, and this is how our insertion sort function will work. And this is the basic working of behind this function. So you can see, and you can analyze, and you can just do it yourself in your editor and compile it yourself. So thanks for watching.